This is 75, chapter 3. Let's zoom in, and we're talking about relative velocity. So, just to recap, in this problem, we have a flock of ducks trying to migrate south for the winter, but they keep being blown off course by 12 meters per second. The ducks realize that if they fight against the wind, they'll be able to travel faster, and they're going to go at a speed of 16 meters per second relative to the air. So, to write that down and kind of break down what that means, we have three components that we're kind of looking for here. So, the velocity of the ducks relative to the ground, the velocity of the ducks relative to the air, and the velocity of the air relative to the ducks. So, ducks are flying south, so velocity of the ducks relative towards the ground, the direction that they are traveling is, the magnitude that they're traveling is unknown. The direction is on the negative y, so we look at our table here. This is velocity of ducks traveling to the ground. They're going straight south on the y-axis, okay? Next thing we want to look at is velocity of ducks relative to the air. So that, our velocity is known at 16 meters per second, but at which direction, we're not 100% sure. And then the last thing is velocity of air relative to the ground, so that's the wind that's pushing the ducks the opposite direction. So velocity of air relative to the ground is 12 meters per second, and we're just sticking that right there on the x-axis. What we're trying to find here is this angle that the ducks need to travel so that they can travel at a speed of 16 meters per second and not be blown off course. So, the way that looks, we're looking right now just in the x-axis. So velocity x of dg equals velocity x of dA plus velocity x of ag. So, recap, dg, ducks relative to the ground, equals velocity of ducks relative to the air plus the velocity of ducks relative of the air relative to the ground. So this plus this gets us this. That's what we're looking at here to find that straight south direction. What we do not know is actually the velocity of x relative to the ducks and the air. So what we're looking for is that. And we can recognize that velocity of the ducks relative to the air is just the sine of theta, the negative sine of theta. And then we can take that knowledge and plug it into the equation. So velocity of ducks relative to the ground, we know in our x-axis our velocity is going to be 0, which equals negative 16 multiplied by the sine of theta plus velocity of air relative to the ground, which is 12 meters per second. We rewrite that, subtract our 12, divide our 16 to get sine of theta by ourselves. We get 12 over 16, which equals 0.75 meters per second. And then what we want to know, so right here, this is 0.75 meters per second. But what we want to know is this, so we just do the inverse sine of 0.75, and we come up with 49 degrees. Oops, pause.